In this lesson we study the polarization of light, and Malus's law. The transmitted intensity equals I0 cos²θ. Light propagates along the y-axis. The transverse plane is spanned by x and z. Unpolarized light has an electric field oscillating in every direction transverse to the ray. We now insert the first polarizer at y equals 0. A polarizer transmits only the component of the field parallel to its transmission axis, here aligned with z. After the sheet, the wave is linearly polarized along z. Next we add a second polarizer, called the Analyser. When the two transmission axes are parallel, θ equals 0, and all the light passes through. With axes aligned, the transmitted beam remains unchanged downstream. We now view the Analyser end-on, and rotate it by an angle θ. Rotate the Analyser by 35 degrees. The incident field E0 splits into a parallel component E0 cosine⁡θ that is transmitted, and a perpendicular component E0 sin⁡θ that is blocked. Intensity is proportional to amplitude squared. Hence Malus's law, I equals I0 cosine²θ. We clear the vector diagram and open the Malus graph. The graph plots normalized intensity 1 over I0 against the angle θ. A live table tracks the values. The red dot moves along the cosine squared curve as we rotate the Analyser. At 30 degrees, I over I0 equals 0.750, which is cosine squared of 30 degrees. At 45 degrees, I over I0 equals 0.500, which is cosine squared of 45 degrees. At 60 degrees, I over I0 equals 0.250, which is cosine squared of 60 degrees. At 90 degrees, I over I0 equals 0.000, which is cosine squared of 90 degrees. We extend the experiment beyond 90 degrees, viewing the Analyser end-on again. The Malus graph now spans 0 to 180 degrees. At 120 degrees, I over I0 is 0.250. The dot follows cosine squared θ on the extended curve. At 150 degrees, I over I0 is 0.750. The dot follows cosine squared θ on the extended curve. At 180 degrees, I/I0 is 1.000. The dot follows cos²θ on the extended curve. Finally, we trace Malus's law through a full 360-degree rotation. The complete cosine squared pattern repeats every 360 degrees. At 210 degrees, I/I0 is 0.750 on the full period cosine squared graph. At 270 degrees, I/I0 is 0.000 on the full period cosine squared graph. At 360 degrees, we return to full transmission. I/I0 equals 1.000. The complete Malus curve is now traced. In summary, polarized light has its electric field in one plane. A polariser passes only the parallel component. The transmitted amplitude is E² cosine θ, so the intensity is I² cosine squared θ, Malus's law. At 90 degrees the beam is extinguished completely.